Thanks everybody for coming, and thanks to the organizers, and especially to Marie for bringing me here. I'm really happy to be back, and feeling much better than 5 years ago. If you were here, then you saw me at the end of my talk go very quickly, and that's all, and run off stage, so it won't happen today. I'm an artist based in Los Angeles. I studied philosophy, computer science, art, and music, but I want to know, who are you? Please raise your hand if you're a student. Who in the audience is a student? A lot of students. Raise your hand if you're interested in art or call yourself an artist. Awesome. A lot of people. Design? Yeah. Wow. Intersectional. Music? Yeah, you're my people. Raise your hand if you've ever written one line of code. Yeah. All right. Okay, and the hardest question, have you seen my work before? Anybody? A few people. Perfect. That's the way I like it. So for everyone who hasn't seen my work, I want to share a few older projects before launching into some of my recent research. Some of my work involves building really immersive installations. This is called Social Soul with Lauren McCarthy. We wanted to explore what it's like inside someone else's mind, surrounding you with content from social media, and completely overwhelmed by the internet. So first, when someone walks up, they type in their Twitter username, and the installation shows all the text and images from their account in rapid succession, with text-to-speech kind of bringing their words to life. And all this content is used to pair the visitor with someone who's similar, who has walked through the installation before. It sends them both a tweet to let them know they've been paired up, that they're social soulmates. Sometimes I'm filling spaces with things, instead of monitors, it's speakers. So this piece is called Missing. Another big space filled with a lot of technology that creates this kind of strong impression through mostly multiplicity and this kind of curated chaos. We've got this room of 50 speakers that follows you around as you walk through the space. This was with the band The XX and Aramik and Matt Metz. They play a spatialized version of this song from the XX called Missing. We wanted to create something kind of eerie and exciting, and play with this contrast between feelings of kind of warmth and familiarity versus like the coldness and robotic movement. Sometimes the technology in my work's really hidden from view. This is another immersive piece called Light Leaks. We point multiple projectors at 50 disco balls and map every single reflection of light using some computer vision techniques. This allows us to control the space like a big LED display. This piece is produced by Juliette Bibas, who's also here at KIKK. The technology here is in the kind of complex process of calibration. It's not really in front of you like the speakers or the monitors. But when everything's finished, we like it to feel like it's this kind of magical coincidence. I feel like computers are currently changing the way we look at ourselves by processing and collecting information about us and representing this information using computer vision or machine learning algorithms. I'd like to imagine that we can take a more active role in this process. Maybe somewhere in all of the data and the algorithms, we can find a new version of ourselves that looks more like the person we want to become. Okay, let's talk about those algorithms. Right now, machine learning and AI are really popular topics. Here's what those acronyms AI and ML mean if you haven't heard that already. To be clear about their relationship, machine learning is kind of one approach to creating artificial intelligence, but sometimes people use these terms interchangeably. I'll talk a little bit also about deep learning, which is kind of one specific kind of machine learning. What is this whole thing about? What does actually intelligence mean? How do you define intelligence? It's not so clear what it means, but maybe we should start there. Maybe you think of intelligence like IQ or intelligence quotient, where some people have more, but most people are about average, around 100. These slides were borrowed from a Japanese tech company, SoftBank. They presented them as part of their 300-year plan to their shareholders, and they imagine artificial intelligence as having a really high IQ. You can see they wrote 10,000 assumption. But I think IQ can be kind of misleading and even dangerous. French artist Edgar Degas said, The day when people began to write intelligence with a capital I, all was lost. There's no such thing as capital I intelligence. One has lowercase I intelligence of doing this or that. One must have intelligence only for what one is doing. I think when we say humans are intelligent, we're usually referring to a big collection of abilities or behaviors that we have. Things like constructing explanations, remembering things, answering questions, and so on. Intelligence isn't just one of these things, and it doesn't require all of these things. I'd say that each of these things is one kind of intelligent behavior. So when we talk about artificial intelligence, we're usually talking about automating a task that normally requires these abilities from humans. Besides IQ, I think there's other ways our understanding of intelligence is oversimplified. If I ask you what makes humans intelligent, you might point to your big brain. Relative to our body weight, our brains are pretty big, but it's not that simple. I threw in Crow over there if Jenny's in the audience. Here's an MRI scan of a French civil service worker who had his head filled almost completely with cerebrospinal fluid. That big dark area in the middle of the skull is that fluid. He didn't know anything was wrong, totally normal dude, until he visited the doctor complaining about strange leg pains and found out he basically didn't have a brain. I think we also oversimplify who is responsible for intelligence. Let's listen for a moment to this recording of an automated phone call.
Hi, I'm good. How are you?
Well, I'm calling about an online request you once made about health insurance coverage.
Okay.
I work with all major companies and compare...
Hey, are you a robot?
What? No, I am a real person. Maybe we have a bad connection. I'm sorry about that.
Oh, that's crazy. I see you just sound so much like a robot.
I am a real person. Maybe we have a bad connection. I'm sorry about that.
Will you tell me you're not a robot? Just say I'm not a robot, please.
I am a real person.
I mean, I believe you, but will you just say I'm not a robot? It'll make me feel better to hear you say it.
There is a live person here.
But I know...
Okay, it turns out it's true. They are a real person, surprise, surprise, but instead of speaking for themselves, they're pressing buttons that play pre-recorded messages, and they just didn't have a I'm not a robot button. Researchers discovered that we're more likely to talk to someone if they have the same accent. So they use different recordings, these call centers use different recordings depending on who they're calling. In a way, there's multiple intelligences represented here. It's a kind of composite system that's stretched over time and space, from the original recordings to the interactive playback. We can't really point to a single person as having the intelligence. I love this idea of composite intelligence, either made of multiple people or involving machines. I examined this in this piece, Blind Self-Portrait, also with Matt Metz. We use the human hand as an extension of this otherwise fully automated system. The visitor sits down, holds the pen to paper, and when they close their eyes, the machine starts drawing using their hand. The human intelligence in this system is minimized as much as possible, and the visitor is used as this tool in kind of larger apparatus. You could say that the machine's making the decisions and the human's just following directions. The experience of having your hand moved by the machine is really uncanny. I think one of our fears as humans is that machine intelligence will treat us in the worst ways that we've treated each other. When you have your eyes closed in this installation, you really quickly have second thoughts about signing up for this. Intelligence can also involve a whole crowd of people. In 2014, I read this book by experimental French writer Georges Perec called An Attempt at Exhausting a Place in Paris. He sat on this bench in Paris for 3 days in 1974, and he tried to transcribe everything that was happening, down to the smallest details. And to me, his writing feels like this very human act of observation, something that can't be completely automated. For example, he writes, "The rain gets fierce. A lady makes a hat with a plastic bag marked Nicolas. Geneviève Serrault passes by in front of the cafe, too far away for me to get her attention. Some green emerges from a shopping bag. The church square is almost empty. Then 3 people cross it. An apple green car. A 96 bus." He really liked writing about the buses. He was cataloging them very carefully. I was just starting to study machine learning when I read this, and one of the lessons in Perek's book is that it's kind of impossible to avoid categorization. We like to imagine that humans are full of subtlety and nuance, but when we're caught in the moment and really stressed, so many things are lost. What's not lost is really heavily simplified. So with this book in mind, I created Exhausting a Crowd with collaborator Jonas Youngyan. We recorded 12 hours of footage at Piccadilly Circus in London and streamed it online with a tool that allows people to add notes to the scene. We wanted to create a modern version of Perek's work built from a kind of crowd intelligence. There's a few instances where it tends towards surveillance, like here where it says car runs red light. It's this moment where the crowd of people using the website act as an extension of authority. When you have access to like an all-seeing eye, it's really tempting to just play the role of the police. But most of the time, it's kind of surreal, absurd observations, like these bins communicating their true purpose. We shot from 3 p.m. to 3 a.m. And there's all these really beautiful melancholy moments in the middle of the night, like these two people riding the bus. This is one of my favorite sequences. It was added really early in the project by a few different people. Each person visiting the website added a few more notes on top of the previous ones that were left there, so chaining them together to kind of create this narrative. So watch the couple walking in from the bottom right corner. And this is like zoomed in to the top left corner of the piece. This is like a relatively small detail of what was happening at 1 a.m. And so then I says to Mabel, wait, look over there. Kiss me, you fool. Gotta pee. What, right here, right now? Yes, kiss me right on the lips. Couple kissing. Oh, how do I get her back to my flat? Do you think anybody's recording us? Exhausting a Crowd's still online, and we've introduced 3 additional locations. One big lesson for me was that when you have a lot of data, it still takes humans to make a story out of it, to really understand it. Machine learning isn't at a point where it can tell these stories itself, but even if it was, I'm not sure we'd want it to. Let's look at some examples of what machine learning can accomplish right now. To be clear, machine learning just means programming computers using examples instead of instructions. Normally, when you're writing code, you're giving the computer instructions of what to do. The examples I'm going to give here are based on a machine learning technique called deep neural networks, or deep learning. If you have a bunch of example photos with labeled categories like leopard or mushroom or cherry, then neural nets can build up a kind of connection between them, predict the category of a new photo that you feed it. When this research was published in 2012, it represented a major breakthrough, and now it really powers a lot of products. If you have example photos with captions, then neural nets can predict the captions for new photos. So here, for example, in the center, it generated 2 hockey players are fighting over the puck. If you have example phone call conversations, neural nets can learn how to correspond in new conversations. So I'm going to play a recording from this software called Duplex, which is currently in development by Google. It's designed to call shops and ask for hours, schedule appointments, or place orders on your behalf. It's kind of designed to sound like a human.
How can I help you?
Hello?
Hello, what's up, man?
Hey, I wanted to know what are your hours for today?
10 a.m. to 6:30 p.m.
Okay, got it. Thank you for your time.
No problem, sir. Bye.
This is completely different from the early example. It's not using any pre-recorded messages. There's no one pressing buttons. They might have collected this big database of calls from all the free Google phone numbers they were providing over the last 10 years. It's not really clear. If you have examples of conversation from someone in particular, then
neural nets can also imitate speech from a specific person. This is an example from a company called Lyrebird, spoken using my voice.
In some cases, it makes sense to call this training by example, a kind of imitation. In this case, a neural net's been trained to imitate the style of a painting. At the top center, the net created the photo on the left in the style of Van Gogh's Starry Night. and then again in the style of Munch and Picasso and Kandinsky. A more extreme version of this not only imitates textures of a painting, but the entire aesthetic of an image. So in this case, the two pictures on the right were created automatically from the two on the left. This seems like it should be really difficult, like sketching from a photo or imitating Van Gogh should require a human with years of arts education. But in some sense, every kind of imitation can be reduced to copying examples. With enough examples of short videos divided into different categories, neural nets can imitate these videos. I recommend not looking too closely at the baby ones. With these really impressive examples, I think about this question a lot. When is human authorship non-essential, especially in the arts? For me, an example is a good meal, or some kinds of design and music that are meant to be kind of decorative. I don't always care where it came from, if it tastes good or if it feels comfortable. Alternatively, for me, a personal story or a heartfelt song wouldn't mean the same thing if I knew it was generated by a computer. It's simply imitating human creativity. Instead of representing some kind of personal human expression, it would be more like a remix or a distillation of human culture, everything it's learned from. Some artists are really pushing the aesthetic possibilities of these algorithms right now. Considering machine learning is typically used to power products like spam filters and music recommendation systems, advertisements, or face recognition, this is quite a departure from the intended use. Personally, I'm more interested in what happens when we use these algorithms behind the scenes instead of just for aesthetic purposes. For example, it turns out that the same thing that makes machine learning good at imitation allows it to be good at learning about this concept of similarity, what's similar, what's different, just from looking at a big chunk of data. This can help us find connections in really disconnected data. This is a project called Terra Pattern, an open source tool I helped build, which provides similar image search for satellite imagery to help the public find patterns of interest and democratize geospatial intelligence. It's ideal for locating infrastructure that isn't usually indexed on maps, indicated on maps. For example, when you click on one container yard, then it shows you other container yards, or it works just as well with cul-de-sacs and sand traps or power lines, tennis courts, or in this case, maybe we're looking for some kind of boats that are moored in the middle of the ocean. Oh, I guess this is circular features. We can also analyze sounds for similarity and use an algorithm called tsni to plot these sounds in a kind of searchable interface where similar sounds are close together and different sounds are far apart. So if you want to try this for yourself, check out the project Infinite Drum Machine. I'll play a little example of a kind of experiment I've done in this direction.
Welcome. Welcome. Hello. Hello.
Hello.
I also use search by similarity for my piece Sharing Faces to help friends find a connection across borders. We installed the same kind of software and hardware in two locations between Japan and South Korea. When you walk up to the installation and explore it, it automatically finds someone with a similar expression from the other country. I think this direction of machine learning in the context of relationships is equally exciting and scary. The philosopher Pierre Levy says, what remains after we have mechanized agriculture, industry, and messaging technologies? The economy will center on that which can never be fully automated, on that which is irreducible, the production of the social bond, the relational. So I'd like to share two pieces I've created with artist Lauren McCarthy that fits in this theme. This piece is called Us Plus, and we created a system that automatically tracks your voice and facial expressions and gives you suggestions about how to have a better conversation.
Hi Claire, how
How's school treating you?
I'm doing okay right now. I'm just kind of annoyed because there's this girl named Stacy in my yoga class who just got pregnant, and she won't stop talking about it. And I just feel like she's being really...
Technology has made us more connected than ever. Shouldn't it help us get more from each other?
She just won't stop talking about her pregnancy and what yoga moves that the whole class should not do because she can't.
Us Plus gives suggestions based on speech analysis and facial expressions.
Now it's just everything is... how are you doing, Mom?
Well, actually, things haven't been all that great. I wasn't sure whether to tell you this, but,
More honesty, more balance.
I feel like we're barely communicating, and sometimes it's just not the same. I try to talk to you and you don't respond, and I can't even...
I love you.
It's been so long since you said that.
More connection.
It's looking pretty bleak. And our profit margins fell last quarter. But I think we can turn things around. If we outsource step 4, we should be okay.
We could also get it down 5 cents more if we use cheaper materials in steps 19 and 23, and the public will never know.
I like how you think.
More productivity, more success. Get more out of your conversations. Us Plus.
And I want to share one more. This one's called People Keeper. We created an app that uses a heart rate monitor to track how different friends affect your mood and automatically manages your social life.
We only have so much emotional bandwidth.
Bring it in.
And limited time.
Mustafa?
Our social circles are widening.
We don't know. That's bad.
All those relationships
Anything in general that makes you excited.
Just...
can be overwhelming. Now, there's an app. People Keeper tracks your physical and emotional response while you're hanging out. And it analyzes the data to identify who stresses you out, makes you excited, sad, or happy. See how your relationships stack up. And let People Keeper find the ones that work for you. It'll automatically manage your relationships, so you don't have to. Scheduling time with people that make you feel good. And blocking the ones that don't. Forget fake friends, failed romance, and FOMO. Optimize your social life with People Keeper.
So these are both real apps. You can download them and use them, try them out. One of my goals in making this kind of artwork is to create a space for reflection on the technologies in our everyday life and how they're affecting our society. I want to create space for building an intuition for machine intelligence and automation. If we don't take the time to reflect, we'll fall into the same traps as the past. This year, I've been working with some friends in Japan to get a feeling for machine learning in the context of dance. We wanted to synthesize machine-generated dances inspired by human dancers. So first, we collected 2 hours of improvised dance over 40 separate recording sessions. Each session features one of 8 dancers from a group called 11 Play in a different style, robot style, sad, cute, etc. Once we have all the data, we worked with a researcher named Parag Mittal to develop a neural net that could process the dance data. We trained the network for a few days, and we started to get output that looked similar to some of our input data. The biggest difference was that the hips are kind of fixed in place, like they're dancing on a bicycle seat. The hips are fixed because we're only modeling the joint rotations and not the kind of global offset of the hip position. But as the deadline for the performance started to get kind of close, we decided to stop the training and work with what we had. The network was generating a sort of not quite human movement that was still somehow reminiscent of the original motion, and it felt really appropriate for the feeling we were trying to create in the performance. During the performance, the real dancer, Maru, starts the scene by exploring the space around the virtual dancer, keeping her distance with a mixture of curiosity and suspicion, and then eventually she tries to imitate the dancer here. For me, that's one of the most exciting moments. It represents this transformation of the human movement passed through a neural net, once again embodied by the dancer. The generated motion is then interpolated, kind of mixed with the choreography to produce this slowly evolving duet between Maru and the virtual dancer. during this process, the rigged 3D model kind of comes to life and changes from this silvery 3D blob to a textured dancer. And I think this represents for me the way that life emerges when creative expression is shared between people, the way that sharing can complete something that's otherwise unfinished. As the scene ends, like you saw, the virtual dancer kind of tries to get off the stage, but Maru backs up and in the same direction with her palm outstretched, and virtual dancer transforms back into this blob and is left kind of alone in its unfinished state without a real body or human spirit left to complete in this collaborative dance. We were really inspired by this research project called Everybody Dance Now, where they generated videos of people dancing based on a sample recording of them moving around kind of randomly. And we wanted to incorporate this into a recent performance of this piece called Discrete Figures, which includes some of this AI-generated dance and a lot of other stuff like drones and motion capture and AR. We set up a booth for people to record short videos before they went into the theater, and we used this as input to an algorithm that learned how to generate dance videos. We only had about 15 minutes to train the model before the lights went down, so we synthesized the dance during the training process. We're actually generating the images while we're training the neural network. This means the first images in this sequence look kind of blurry and unclear, but by the end of the scene, they start to resolve into more recognizable details. I'm going to skip forward here. We also show this overlay of the best matching frame from the original video recording. Here's what it looks like in the context of that debug scene. While Maru has a chance to experience this process of her dance being reimagined by the machine, this final section gives the audience a chance to have that same feeling. It follows this theme that's kind of recurring throughout the entire performance of seeing ourselves, seeing our humanity reflected in the machine and vice versa. The same techniques that allow us to understand body movement are also being used to understand faces. I've been working with faces and computer vision since around 2010. I showed this example earlier. This video is from one of my first experiments with face tracking. I really love how deeply this technique has embedded itself in culture. This is one of my favorite face swapping videos ever. But most people working with computer vision and machine learning aren't designing for playful interactions or designing systems to help build intuition. Some of them are even doing blatantly dangerous research, like this research paper used profile photos from a dating website combined with data about the profile's gender and the gender of the person they're seeking to train a neural net to predict sexual orientation, which they defined as gay or straight. They found that the model worked pretty well, actually better than humans at predicting one of those two categories. And they used this to make kind of questionable connections between sexual orientation and biological factors like testosterone levels. Other researchers are attempting to predict whether someone's a criminal based on their appearance. You can see it says the 4 subtypes of criminal faces on top. Those are the most criminal-looking people, and the 3 subtypes of non-criminal faces on the bottom. Or they're rating how attractive someone is based on their appearance. For me, this really hammers home what's wrong with this situation. We're really good, actually, as humans at judging each other based on how we look. We do it all the time. We often even agree about some of these things, like who is and isn't attractive. But I don't think this is necessarily a good feature of humanity. I don't want to bake this into an AI. Just because estimating attractiveness could be one of those tasks on that list of intelligent behaviors from earlier, it doesn't mean we should automate it necessarily. We have a history as humans of creating taxonomies and trying to categorize people based on the way we look for all of history, from physiognomy to Chinese face reading, but it seems that every attempt to pick a single category to describe people has pushed us farther apart from each other. Jenny Odell gave a really amazing talk about this earlier today. This is another question I've been asking myself as I look at all this work. What features of humanity do we want to automate? Maybe not making assumptions about people based on the way they look, but there are things I would like to see automated, like positive aspects of humanity, like being open to change in ourselves and others, or being able to put others before ourselves. Some things seem really clear-cut and well-defined when it comes to like computer vision, machine learning tasks involving appearance, like facial expressions. We divide them up into 6 or 7 categories if you add neutral. But facial expressions are even very complex in themselves. I want to play this excerpt from a Japanese TV show where the 2 contestants are trying to make each other laugh. Most of these expressions don't have any names. Saying, good luck, you can do it. Even with something as simple as face expressions, we can't put names on all of these things. If we look at the training data for some of these data sets that the researchers are using, it can be really inaccurate too. So even though we have this problem of categorizing, we also have this problem of collecting. These are some examples I found in a really popular data set for training face expression recognition systems. It can be hard to have an intuition for how well these algorithms work, so I want to give a quick demo of what it looks like for these algorithms to run in real time by showing an example of face analysis. I'm going to switch to showing you my screen. 1 second. All right. That should be up there. Great. All right, so this is looking at my face right now. And it looks like I'm happy because I'm on stage. And it knows when I'm surprised and sad and, let's see, I'm not very good at getting angry. Hold on. Okay, let's move on. Disgust, maybe. Yeah, there we go. All right, fear. It looks a lot like sadness. Okay, I have to try contempt. This is the hardest. Yeah! Did you see it wiggle? Yes. Okay, I want to try one more example. Let's look at this. All right, what are some categories we have here? Maybe smiling. We have some more expression categories. Not big nose. Okay, fair enough. Eyes open. All right, does it say my eyes are closed now? I can't see. No? Okay, a little inaccurate. How about the teeth? Oh, it's got that. Teeth not visible. Beard, goatee, double chin is low. Color photo accurate. Rosy cheeks. All right, let's switch back. I want to talk about this for a second. For me, it feels really dangerous when a machine decides not just how we look, but who we are. In that last example, you might have noticed some of these categories like Black or Indian, and these feel particularly problematic to me. So recently I've been trying to work on reproducing some of the most problematic research that I can find. These things like estimating whether someone's a criminal or where they're from. I want to understand what kind of trade-offs and assumptions the researchers had to make when they were doing this. I'm working with one data set that includes 2 million faces from Flickr with geotagged locations. The researchers who compiled this data set are interested in predicting where someone's from based on how they look. To reproduce this research, I started by dividing the photos into 20 geographic locations, or 20 geographic subregions. And this image shows the averages from each subregion. And then I trained a neural net to identify which subregion a face is from, kind of similar to what they were doing in the paper. Once I had similar accuracy to the original research, I was getting similar results, I asked the net to show me some representative photos from each subregion to kind of check my work. Like, I would ask, who looks the most Central African out of all the photos? And the answer was sort of surprising. It turns out that this guy is the most Central African according to the neural net. You have to remember that this net is like 70% accurate at identifying where someone is from according to this data set. So I thought this was a bug at first, but turns out what happened is this guy was backpacking through Africa and took a photo of himself in every single town and uploaded it to Flickr. So the neural net kind of like fell in love with his face because it was so useful. So I checked some other places and they had similar problems. You might have noticed this slightly purple face. That's Scandinavia. It turns out a lot of Flickr photos from Scandinavia are from concerts and nightclubs, and they really love using purple light, more than anywhere else in the world, apparently. In East Asia, the most representative face is the Buddha. And in the Middle East, it's the face of Jesus. Most of these are from the Deisis mosaic at the Hagia Sophia in Istanbul, and in some ways it feels really appropriate that this 13th century mosaic would be captured by hundreds of people, posted to Flickr, and then become this defining representation of the whole region for a neural net who's trying to understand humanity. Treating purple-colored people as Scandinavian isn't really a big problem, but as I dig deeper into reproducing this research, I'm reminded that there's these same kind of biases in every data set, even if it's been collected from millions of people around the world on Flickr. Machine learning is really good at doing this kind of imitation, like all those examples I showed earlier, but this strength of being able to imitate becomes a weakness when the input data is already biased. For example, in the US, where I'm from, it turns out that an automated system that predicts whether a criminal is likely to reoffend after being released from prison is biased against black people. This is an imitation of ongoing systemic racism in the US, and it's affecting real people right now. I want to finish by saying I think we can do better than this. We don't have to relive the same mistakes we made before. As creative people in this room, I think we can explore these algorithms ourselves and find ways to kind of share them creatively, understand them, deconstruct them, and reimagine them. Thank you.